Hello everyone, welcome to EduRev. Today we will study the topic of Venn diagrams. Now, logical diagrams based situations have their own importance in the context of preparing for any aptitude exam, especially your CAT. There are three major types of questions based on diagrams. Let's see what are those. So they are the numerical questions on set theory based on Venn diagrams, then the logical questions based on set theory, and number three, questions based on your network diagrams. Let's take a look at some of the standard theoretical inputs related to what? Your set theory. So firstly, let's see that what exactly is your set theory. Now, set theory is a branch of mathematical logic that studies what? Sets, obviously, which can be informally described as a collection of objects. For example, you can see these two pictures, collection of fries and collection of your pens. So these are what? Your sets. Although objects of any kind can be collected into sets, as we have just seen, but set theory as a branch of mathematics is mostly concerned with those that are relevant to mathematics as a whole. Now, to understand what exactly set theory is, we need to understand what are Venn diagrams. So let's move forward and understand that what exactly are Venn diagrams. So Venn diagrams. A Venn diagram is a diagram that helps us to visualize the logical relationship between sets and their elements and help us to solve examples based on these sets. So it has to be logical. What? Relations. Alright. Now a Venn diagram typically uses what? Your intersecting and non-intersecting circles to denote the relationship between your sets. Like for example, you have avocados. So there can be two major categories in which you can put your avocados into. One which are not ready to eat and one which are too late to eat. But the intersection of these that are ready to eat is the one which you need to focus on, which is this one, right? So what exactly is Venn diagram? It's going to tell us the logical relationship between any group of sets. Alright, so in easier terms, Venn diagram tells us what? A logical relationship. Let's take an example now. Alright, so now let's observe a Venn diagram which is displayed on your screen. Here the Venn diagram that shows the correlation between a set of numbers. That is, one set contains your even numbers from 1 to 25 and the other set contains the numbers that are multiples of 5 from 1 to 25. Now the intersecting part shows that 10 and 20 both are even numbers and also multiple of 5 between what? 1 and 25. So basically on this screen, you can see this diagram where we have two sets, that is even numbers from 1 to 25. So I'll just find all the even numbers between 1 to 25 and also multiples of 5 from 1 to 25. So it has to be 5, 10, 15, 20 and lastly 25. Now the intersection will give us what? Intersection will give me the even numbers which are between 1 to 25 which are multiples of 5 from 1 to 25. So that is going to be what? My intersection. And this is how basically the Venn diagram, that is this Venn diagram in particular, is representing the logical relation between all the numbers those are even and between the numbers that are multiples of 5 between the set of what? 1 to 25. So I hope you have understood this. Now let's quickly see some of the terms which are related to set theory, or you can say Venn diagrams, so that it's easier for us to analyze what kind of Venn diagrams or what kind of logical relationships are displayed with the help of Venn diagrams, of course, and then it will be very, very useful for us to solve questions with regard to them. So moving further, the first one is your universal set. So what exactly is your universal set? Now, whenever we use a set, it's easier to first consider a larger set that is termed as what? Your universal set, and it contains all the elements in all of the sets that are being considered. Whenever we draw a Venn diagram, then a large rectangle is used to represent the universal set, and it's usually denoted by, as you can see, by U, or we have one more denotation, that is E. So basically, universal set is a bigger set which contains all the elements, or you can say all the sets with which we are functioning. Like for example, in this yellow circle you can see that we have numbers that are multiples of what? 2 from 1 to 10. But all the numbers which aren't multiple of 2 are written where? Outside the circle. But the bigger set, that is the universal set, tell us what? That we have numbers from 1 to 10, that is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So basically a set of all these numbers is going to be what? Universal set. Then in your universal set you will have all the numbers, and in your universal set you will have other sets as well. Like for example, this one is a set of numbers which belong from 1 to 10 and they are what? Even. And all the numbers which are not even and which belong to the group of 1 to 10 are written outside the circle. So this is basically your universal set that contains all the elements in all the sets that are being considered. Now, the image that is given on your screen, U is what? The universal set with all the numbers 1 to 10 enclosed within the rectangle, right? As I have told you that all the numbers are enclosed within the rectangle. So for universal set, we usually use what? Rectangle. So for your universal set, we will use rectangle. Now, A is what here? A is the set of even numbers from 1 to 10, which is the subset of the universal set U, and it is placed inside your rectangle. Now, most people may know what is the meaning of your subset, and most people might not know what is the meaning of a subset. But I am going to explain you that what a subset is in like a few seconds. So just bear with me. But yes, basically the thing is that all the numbers between 1 to 10 that are not even, they will be placed outside the circle as I've told you, and this circle is what? Your subset. But all those numbers will be inside your rectangle only. So basically it's saying that all the numbers that are within the subset of A, they will be inside the circle, and which are not within A, they will be outside the circle, but they all these numbers will be enclosed with what? Your rectangle. So I hope you understand that what is the meaning of your universal set. Now let's quickly move on and understand that what is your subset. Okay, so subset. Alright, so Venn diagrams are used to show subset. So, but what exactly is a subset? A subset is actually a set that is contained within another set. Okay, so a subset is going to be a set which is contained within another set. For example, here A is what? A subset of B. Why? Because all the elements that are present in B are contained, all the elements that are present in A are contained in your B, but all the elements which are present in your B, they are not contained in A. Okay, so let's consider the example only which is given on your screen. As I've told you already that A is going to be a subset of B because circle A is contained entirely within your circle B, right? So that means all the elements of A are within your B, but all the elements of B are not within your A. Now the relationship of subset is symbolically represented as what? That A is a subset of B. And how do we say it? That A is a subset of B, and how do we write it? The way I've just written here, that A is subset of what? B. So I hope you have understood that what is your universal set and what is your subset. Now let's see some of the symbols which are used in your Venn diagram and what are the meaning of these symbols. Okay, so let's understand it. Okay, the first one is your union. Now what is the meaning of union? The meaning of union is or. Okay, or. So whenever I need to represent the word or, just remember that union is the one thing that is used for that. That is, and how do we read it? We read that it is A union B, and it is read as A union B, as I've just told you. Now elements belong to either set A or set B or both the sets is basically what is the meaning of union. Now let me explain you what is the meaning of union with the help of like a diagram which I'm going to draw right now. So okay, let's consider that this is your set A and this is your set B. Okay, so this is your set B, A, and this is your set B. Okay, so the meaning of union is that whatever you are considering, okay, either it should be present in your A, alright, either it should be present in your A or it should be present in your B, okay, or it should be present in your both A and B, that is this portion. Alright, so this is the meaning of your or I can say union. Now let's see what is the meaning of your intersection. Now the meaning of your intersection is and. Okay, so let's again understand how we can draw and. Okay. Now, intersection is basically read as how A intersection B, and it is written like this. Now, elements that belong to both A and B. U is your universal set. So, if I take two sets again, A and B. So, intersection basically means all those elements which belong to both A and B. And the elements which belong to both A and B needs to be these elements, because these are the ones that belong to both A and your B. So this is basically what your intersection. Similarly, let's see that what is the complement. Okay. So what I'm going to do is I'm going to draw a universal set U, and let's suppose that this is a universal set U and this is a subset which is A. Okay. Now suppose I need to find the complement of A. So what is going to be the complement of A? Complement of A is going to be all the numbers, or you can say all the things that are within your universal set but outside your A. Or you can say complement basically means the opposite of A. That means you need to take all the elements which belong to the universal set but which do not belong to A. So that has to be your complement for A. So now I hope you understand that what is your union, what is your intersection, and what is your complement. But let me explain it to you once more. So union means what or? That means either, the number which you are referring to, either it should belong to A, or it should belong to B, or it should belong to A intersection B. Okay. Intersection means and. Intersection means that any number which you are referring to should belong to both A and B. Alright. And complement means the negative, I would say. That is, if you're not exactly negative, I would say, but it's like the opposite. Okay. So for example, if we are considering A, alright, and you want to find the complement of A, so the complement of A will be written as A complement or A dash. So basically in this, what you need to do is you have to find all the elements which are within your universal set, but they are not within your set A. So that will be your what? It will be your A complement. So I hope now you have understood that what is union, what is intersection, and what is your complement. So let's move forward. And there is this beautiful example which is displayed on your screen. And we basically need to find out what we basically have to find out, that what is going to be A union C, then what is going to be A intersection C, then what is going to be A intersection B intersection C, and what is going to be A complement or A dash, I would say, in that reference. Now A union C means I need to figure out all the numbers which are present in A or C. Alright. So if I talk about A, so all the elements that are present in A are 10, 2, 2 and 1. And all the elements which are present in C are 6, 2, 2 and 9. So that means I need to add 1, I need to add 10, I need to add 2, I need to add 2, I need to add 6 and I need to add 9. So when we added them, we got what? 30. Simple, right? Now I need to find A intersection C. So what is the meaning of A intersection C? The meaning of A intersection C is that I need to figure out all the numbers which belong to both A and C. Now you can see that 2 here belong to A itself and C itself, right? So it has to be 2 plus 2, that is 4. Similarly, I'm going to find out a number that belongs to what your A, B and C, all the three. That is a number that belongs to A, that belongs to B and that belongs to C. So that number here has to be what? 2. So that's why we have written 2. And lastly, I need to figure out that what is the complement of A. So when I am going to figure out that what is the complement of A, then it will be what? It will be all the numbers which are within your A, but like all the numbers which are within your A, we need to neglect those numbers. So we do not have to take 10, we do not have to take this 2, we do not have to take this 2, we do not have to take this one. we need to take this 10, we need to take this 6, and we need to take this 9. Adding 10, 9 and 6, we will get 25. So with this example, I'm hoping that you people now have understood that what is the meaning of your complement, what is the meaning of your union, and what is the meaning of your intersection. And also when I am taking intersection of two or more sets. So I hope this was easy and it made a lot of things clear. Now let's move forward and we are going to talk about operations. So what are the meaning of these operations? Let's see. So we know what is union, okay? We know union means or, we know what is intersection, intersection means and, we know what is complement. Complement means what? That you need to take all the things which are not included in the set which is in question, and we know the difference. Difference means we basically need to subtract the elements in a particular set from the elements of the second set. So we will see how we can find the difference between two sets. So let's move forward and let's understand that what exactly is union. Now in simpler terms, if I'm going to explain you as I've done before, union means that if you have two sets, then you need to take all the elements which are in that, okay? So you need to take all the elements, okay? Because suppose there is an element X. Now this X element can be present in B and can be present in A, okay? And it can also be present in both A and B, which is the intersection portion, alright? So that's why if I'm saying that you need to take union of two sets, then that means that you need to like make a set in which all the elements of A and B are present. And that is exactly what we are talking in union. So let's read what is given. So they are saying that the union of two sets, which is your A and B, can be given by this. That means the element should be present in either A or it should be present in either B. Now this operation on elements of set A or B can be represented using a Venn diagram with two circles. And this is how it is, and this is what your U, that is your universal circle, or you can say universal set. Now the total region of both the circle combined denotes the union of set A and B. So union means that whatever number you are picking up, it should be either present in your A or it should be present in your B, or obviously it can be presented in the in both the sets. So basically this is what is the meaning of your union, and to find out the union of two sets, you basically need to what? You need to take the, I would say, union, or you can say the combination of all the elements which are present in both of your sets. Alright, so let's understand how I can write the union of two given sets with the help of a simple example. So let's suppose I have this set A and this set B, and let me write the elements which are present in A and B. So let's suppose that A has 1 and 2, B has 5, and both of them have like 7 in common, and here let's say we have 13. So I know I have a set A in which there are 3 elements 1, 2 and 7, and set B in which it has 3 elements 5, 7 and 13, and 7 is common to both A and B. So if I have to write A union B, then it will be a set containing 1, 2, 5, 7 and 13. So this is going to be what your A union B, that is all the elements which are present in A and B. Now let's move forward and understand what was intersection. Now intersection, as we have explained, that it has to be all the elements which are present in both your A and B, right? So let's understand this as well with the help of an example. So let's suppose I have A and I have B. Again, in your A, let's say I have 1 and 2 and common is 7, and we have 5 and 13. So A intersection B will contain only element 7. That is because that element is common to both your A set and your B set. And this is how we find your intersection. I hope you have understood how we do the intersection as well. It was simple, right? It means that the element should be present in both A and your B, and that is what is your A intersection B. Right? And it's represented how? Using a Venn diagram with two intersecting circles. The region common to both the circle denotes what? The intersection of set A and set B. Let's move forward to another topic, that is what is complement of your set. Now, whenever I talk about complement of your set, so complement of a set means that I need to write all the elements which are not present in that particular set but is present in your universal set. That is the region covered in your universal set excluding the region covered by A gives you complement of A. For example, let's say that this is your universal set U and this is your A. The elements which are present in your A is, let's say, 7, 9, and the elements which are present in your union are, let's say, 13 and 27 and 54. So when you need to write a complement, you can write it in either way. So it will be a set which has 13, 27 and 54. So this is basically what is your complement of a set. That is, we need to include all the elements which are in your universal set, but they are not present in your A. That is your set which is in question. So this is basically what is complement of a set. Now let's understand that what is the meaning of difference of two sets. Okay. So whenever I say that we need to find the difference of two sets, this means that we need to find the region which is covered by A excluding the region that is common to set B, and this gives me the difference of set A and B. Now when I say that I need to find the difference of A and B, so that is A minus B, then I need to include all the area that is only present in A. Only in A. It shouldn't be in B or it shouldn't be in the common region that is between A and B. Similarly, if I say that I need to find the difference of BA, then that means I need to find all the region that is present only in B, and I do not have to include whatever is present in between both A and B and in A. So this is the meaning of your difference. Let's understand this with the help of an example. So let's suppose we have what? We have a universal set and we have two sets, your set A and your set B. So let's say in your set A we have 1 and let's say 3. In your set B you have, let's say, 41 and 79 and common is 8. So if I want to write A minus B, I will write that it is your set that I have to subtract B from it. So it will be only 1 and 3. And if I have to write B minus A, then it has to be 41 and 79. So I hope you people have understood that how do we find the union of two sets, how do we find the intersection of two sets, how do we find the complement of a set, and how do we find the difference of a set. Now to wrap up with this, let's see this diagram. So we know how to represent set A. So this is going to be set A. We know how to represent the complement of a set. Okay. So the complement of set is what? All the elements which are present inside your universal set which is not part of your set which is in question. Then we know what are disjoint sets. Disjoint sets means which do not have anything in common. So they comprise of what? Your disjoint sets. Overlapping sets, or you can say this is the intersection of two sets. Then proper subset means that all the elements of B should be a part of A. And then union means what? That we basically need to take all the elements which are present in A and your B. Okay. So this is basically your union, your intersection, your disjoint sets, your subset, your complement, and whenever we talk about a particular set and the universal set. I hope you people have understood this. Now let's move on to the other interesting topic, that is Venn diagrams for three sets. So let's understand this topic now. See how we can, create a Venn diagrams for three sets. Now till now we have seen that how Venn diagrams for two sets work, and we have learned a lot of topics about the union, about complement, about intersection, about the difference of two sets. But what if the number of sets instead of 2 are 3? So I would tell you one thing which is really very amazing. That is, the basic principles remain same. That is union, intersection, your complement, okay, your, you can say, the difference. These things remain same. But the point is, in place of your two sets, your number of sets would increase to what? 3. Now, three set Venn diagrams is made up of three overlapping circles, and these three circles show how the elements of three sets are related. When a Venn diagram is made of three sets, it's also called a three circle Venn diagram. That is three circle Venn. I'm so sorry. I'll just erase and write it. So it's your three circle Venn diagram. Alright. So this is basically what a three sets of Venn diagram is referred to as. It's referred to as a three circle Venn diagram. And in a Venn diagram, when all these three circles overlap, the overlapping part contains the elements that are what? Either common to any two circles or they are common to all the three circles, right? So let's take the example which is displayed on your screen now. Now the Venn diagram that is displayed on your screen, you can see that we have three sets here, set P, set Q and set R, right? I'll just change the color of the pen. Let's take B. Okay. So we have three sets here. We have P, we have Q and we have R. Now there are going to be regions which is only associated with P, or the region which are only associated with Q, or they are only associated with your R. So let me write everything down, whatever I'm saying, so that we do not have any confusion in understanding the topic. Okay. Alright. So, yep. So there will be area which is only associated with P, so P only. Then there will be area which is only associated with Q, that is Q only area. And area which is only associated with R, that is R only area. And when you refer to the diagram, you can see that we only have area which has P in it, then we have area which is only for your Q, and we have area which is only for your R. Now, other than this, we will also have area which is like with what? P and Q together, then Q and R together, and your R and P together. So for P and Q, you will have this area. This is the area which will be for your P and your Q. Now, if I change my color again, then for your Q and your R, this is the area which will be for your Q and your R. Okay. So I'll just shade it so that you people can see. So this will be the area for your Q and your R. Next, when I change the color again, let's say we take blue. Okay. So for your R and your P, this is going to be the area which is common to both your R and your P. Okay. This is the area which is common to your R and your P. Now lastly, I need to find the area what? The area that is for P, Q and R, all the three. And this area has to be this central part, okay? This your triangle shaped region. This is the area which will contain all the elements which are common to all the three of your sets, that is your P, Q and your R. So I hope you have understood that how three set Venn diagrams are represented and what are the various parts which are there in your three set Venn diagrams. Alright. Now, according to the observations, okay, we can see what? We can see that the elements in P and Q are the elements in P and Q only, plus the elements which are in what? Your PQR. So I think I should write these things again. Eraser. So I'm just going to erase everything. Okay. So let's write the observations which we have observed here. Okay. So they are saying that the elements in P and Q, so all the elements in your P and Q will be what? They will be the elements in your P, right, and Q only, plus your elements that are present in your P intersection Q intersection R, right? Similarly, when I talk about your elements in your Q and R, it will be elements in your Q and R plus elements in your P intersection Q intersection R. And lastly, when I talk about what? We have done P and Q, we have done Q and R. So when I talk about P and R, so it will be elements in P and R only, plus your P intersection R intersection Q. So I hope you have understood that how the intersections in your Venn diagrams are going to work, and what all are the areas which are related to only P, the areas which are related to only Q, the areas which are related to R, and then mixtures of them, that is P, Q, Q, R, R, P, the areas which are only present in PQ, only in QR, only in RP, and the area which belongs to all the three, that is PQ and R. Simple, right? Let's move forward now. Alright, the next topic for the day is how to draw a Venn diagram. Now we have understood that what is a set, what is a Venn diagram, what are the various operations which we can do on Venn diagram, for example, your union, your intersection, your complement, your difference. So once we have understood how we can do this, we have also understood that how to create a Venn diagram in which there are three sets. But how to draw a Venn diagram in first place? So let's understand these steps first, and then we will see how we can actually draw a Venn diagram with the help of an example. So these steps consist of 4 steps. The process consists of 4 steps. Step 1 says that we need to categorize all the items in sets. So all the items which are given to us, we need to categorize them into various sets. Second, we need to draw a rectangle and label it as per the correlation under the sets. Third, we need to draw the circles according to the number of categories which we have generated. And number 4th, we need to place all the items in your relevant circles. So this is basically what they are talking about. So let's go and draw a Venn diagram using an example. And the question states what? The question states that let's draw a Venn diagram to show the categories of outdoor and indoor for the following pets. That is for your parrot, your hamster, your cats, your rabbits, your fish, your goats, your tortoise, and your horses. Now the animals, or you can say the pets which are provided within this list, they will be of what? Of 2 categories. That is either they are your outdoor or they are your indoor, or they are like both. That is they can be either your indoor ones or your outdoor ones. Alright. So basically firstly what I need to do is I have to categorize them into indoor and outdoor. Okay. So we will write the name of all the animals which are indoor and outdoor, and also which are in like both. Okay. So when I talk about indoor, I can say that parrots are indoor, your hamsters are indoor, then your cats are indoor. For your outdoor, I can say that goats are outdoor, then your tortoise are outdoor, then horses are also outdoor, and in both I can say we have rabbits and we have fish. So we basically have pets that are indoor ones, the ones that are outdoor ones, and the ones that belong to both the sets, that is indoor and outdoor. Now once we have categorized this, the next step is to draw the Venn diagram. So let's draw the Venn diagram, and for that I need to erase this. Hope you people have jotted this list in your notepad, or you have taken a screenshot or something. So let's like erase them. Okay. So now the first task is to draw your universal set. So I'm just going to draw my universal set. I'm sorry. Just erase it. So yeah, this is kind of okay. So this is like my universal set, and we have the indoor ones and the outdoor ones. So this is my universal set. This is indoor animals. These are your outdoor animals. So outdoor and indoor set. So now we are going to write the names of these animals, okay? So parrots are indoor, then hamsters, indoor animal, then your cats, again your indoor animal. Then when I talk about the outdoor ones, we have goats, we have tortoises, and we have horses. Then the ones which belong to both the sets, I'm just going to write them here because I don't think they will fit in there. So we have rabbits and we have fish. Alright, so we have completed this question. I hope you have understood this. Now let's just, quickly recap all the concepts which we have done till right now, like till this moment, so that we can, use them in the further questions which we are going to solve now. So now the first things first, this is the area that is only related to my indoor animals. Similarly, if I change the color and show you, this is the only area which is for what? My outdoor animals. Similarly, this is the area which is for both my indoor and my outdoor animals. Now, if I want to take union of the set, so the union of the set is going to be a set which contains all the animals, that is your parrots, your hamsters, your cat, your rabbits, your fish, your goats, your tortoise, your horses, everything. If I want to take intersection of these two sets, the intersection will contain your rabbits and your fish, right? Now, if I want to take, suppose, complement of your indoor animals. So the complement of your indoor animals will be what? The ones that are present in your outdoor, that is your goats, tortoise and horses. Similarly, the complement of your outdoor will be what? The ones that are present in your indoor, only in indoor, that is parrot, hamsters and cats. And similarly, if I want to do like, the difference of A and B, so it will be the animals which are only present in your A, that is parrots, hamsters and cats. Similarly, the difference of B and A will be the elements, or you can say the animals which are only present in your B and not in your A, which are your goats, your tortoise and your horses. So now I hope you have understood the topics and the way we can draw the Venn diagram, what are the various parts of Venn diagrams, how we can say that when one set is your subset or your universal set, what is union, what is intersection, what is complement, what is difference, so all the operations. So now let's move forward and solve a few questions. Alright, so let's solve this question now. This question says that in the following diagram which is given to us, that is this particular diagram, who are athletic and disciplined and are indicated by which number? So basically what they are asking us to do is we need to find the number of people who are what? Who are athletic and they are disciplined. Okay. So when I see this, athletic is represented by a circle and disciplined is represented by a rectangle. So this is basically the rectangle which we are talking about. This. Okay. This is the rectangle which we are talking about. And this is the circle which we are talking about. So I basically need to find out the numbers which are represented by both of these. Now when I talk about disciplined one, okay. So when I talk about the disciplined one, that is the rectangular one, let's write down all the numbers which are within this. That is your 10, your 6, 2 and 1. 2, 1 and 3. So we have 10, we have 6, we have 3, 2 and 1. When I talk about athletic, it includes your 7, your 6, your 2, 3, 5 and 4. So the numbers which are common to both of them will be what? So we have 6 in both, we have 2 in both and we have 3 in both. So the set, the answer will be what? It will be a set which contains 2, 3, 6. I hope you have understood this question. Now let's move on to the next question. Alright, so the next question says that in a college of your 200 students, that means the total number of students are what? 200. So let me write it, okay? Total students are what? 200. Then it's asking that 140 of them like tea, 120 like coffee, and 80 like both of it. That means people who like tea, who like coffee, and who like both. So I guess for tea it was 140, then 120, and then 80. So 140, 120, and 80. Okay. So we need to find out how many of the students like only tea, how many of the students like only coffee, how many students like neither, how many students like only one of tea or coffee, and how many like at least one of the beverages. Okay. So let's draw like a Venn diagram to represent. Okay. So let's suppose that we have, this is my universal set. We have the people who like tea and the people who like coffee. So this is for tea and this is for coffee. Now the ones that like both are 80. So that means 80 are the people who like both tea and coffee, right? Now the people who like tea are 140. But out of 140, we have already written 80. That means 140 minus 80, which is your 60, will be the people who only like tea. 80 will be who like both tea and coffee. And when I want to talk about coffee, the people who enjoy coffee are 120. But out of 120, 80 are the people who like both. So 120 minus 80, that means 40 people like only coffee. So this means what? This means that 40 people like only coffee, 80 people like both tea and coffee, and 60 people like only tea. Now the point is that when I add all of these, so 60 plus 40 is what your 100, plus 80 is what your 180. But the total number of students are what? 200. That means 200 minus 180. 20 students are the one who do not like coffee or tea. So those 20 students will be included in your universal set, but they won't be included in either of your set. That is either in the set that like enjoys tea or in the set that enjoys coffee. I hope you have understood this now. So now let's go and answer the questions. So the first question is how many students like only tea? The number of students who like only tea will be 60, right? Because 80 are those who like both tea and coffee. So only 60 are the people who like only tea. So the answer will be your 60. I'll just erase and write it again. Okay. So the answer is going to be 60. Then how many students like only coffee? For only coffee, we can say that 40 students like only coffee. So again, I'm going to write 40 here. Then how many students like neither tea or coffee? So that means they are not included in either of the set. So there are 20 students who are not included in either of the set. So I'm just going to write 20 here. Then how many students like only one of tea or coffee? That means either they like only tea or they like only coffee. So for only tea we have 60 people and for only coffee we have 40 people. So in total 100 people are the ones who like only one of tea or coffee. And lastly, how many students like at least one of the beverage? At least one of the beverage means they either like only tea or they like only coffee or they like both of them, because at least they need to like love one beverage and at max they can love two of the beverages. So in totality we have how much? 180. So I'm going to write 180 here. I hope you people have understood this question as well. Now let's move on to the next question. Alright, so let's see how we can solve this question. Now this question says that which are the numbers that make their presence felt in only one of the geometric figures. That means that particular number should only occur in one of your geometric figures. So let's see what those numbers are. Now if I'm going to like, alright, so let's observe the numbers right from the left hand side. So when I talk about 2, this 2 is only represented in the rectangle, right? It's not in any other geometric figure. So I would write 2 in the set of my answer. Then we have 3. Now this 3 belongs to this rectangle that is represented here horizontally and the other rectangle that is represented here vertically. So we cannot take 3 as in our answer. Then let's observe 6. Now this 6 is within this circle and within this vertical rectangle as well. So we cannot take 6. This 8 is in your circle, in your vertical rectangle and in your horizontal rectangle as well. So this is the vertical rectangle, this is the horizontal rectangle, this is your circle. So this 8 is present in all 3, so we cannot take this. Even your 4 is similar to 6 because it's present in your vertical rectangle and in your circle. So we cannot take 4 as well. When I talk about 1, 1 is only present in your circle, so we can take 1 in the set. Then we cannot take 7 because 7 is in your horizontal rectangle and in your circle as well. So we cannot take 7. Lastly, we have 9. Now 9 is only represented in your horizontal rectangle. So we will take 9 as well. So these are the numbers which make their presence felt in only one of the geometric figures, and the set is what? Your 1, 2 and 9. And if I write them in order, it will be what? 1, 2, 9. So these are the numbers whose presence is only felt in one of your geometric figures. Let's move forward now to the next question. So the next question says what? The next question says that which of the following Venn diagram correctly illustrates the relationship among the classes, that is tennis fans, cricket players and students. Now just tell me one thing. Can students be cricket players? Okay. So I will just write T for tennis players, C for cricket players and S for students. Okay. So just answer a few questions of mine, and by the end you are going to answer all these questions of mine. You will automatically get the answer for your this question. So now the thing is that can students be tennis fans? Yes, of course they can be. Can students be your cricket players? Yes, of course they can be. And can your tennis fans be cricket players? Yes, they can be. And vice versa. Your cricket players can be your tennis fans as well. This means that all these sets have something common with each other. And it might be that the students are both the players, cricket players, and the tennis fans as well. That means there is something in common with all these 3 sets. So don't you think this should be the way we should represent, the classes? That is your tennis fans, your cricket players and your students. That is option A. Right? This is exactly how we need to represent, because some students can be cricket players, some cricket players can be your tennis fans, some students can be your tennis fans. So given the items are partly related to each other, we can make this. Alright. So it can be what? It can be that we have these 3 circles. Okay. So this one can be your tennis fans, this can be your cricket players and this can be your students. So I hope you have understood this. Now let's move on to the last question for the day. And this last question says what? It says that in a school of 150 students, 150 students as in totality we have how many students? In totality we have 150 students. And in a school of 150 students, have to opt for at least one subject out of your English, your physics, your mathematics. So there are 150 people in the school and they have to opt for at least one subject, that is either your English or your physics or your mathematics, right? Now if 71 students opt for English, 98 students opt for maths and 68 for your physics. So 71 are for English, 98 are for maths and 68 are for your physics, and 14 opted all 3 subjects. Then we need to find the number of students who opted for exactly 2 subjects. Now this is like a very interesting and a very easy problem. Now let ABC be the sets of students who opted for what? Your English, physics and mathematics respectively. So I would say ABC for English, physics and mathematics respectively, right? Now we know that the total number of students is what? 150. So the total number of students is 150, which can be represented how? By the union of ABC. Correct. That means A union B union C will be what? It will be A plus B plus C minus A intersection B minus B intersection C minus C intersection A and adding A intersection B intersection C. Now let's understand how and why did I wrote this. Now the point is that if I draw these three, A intersection B intersection C, we all know that this is basically A plus B plus C. Now because I've considered all the A, all the B and all the C, don't you think the sections that are common to AB, common to BC and common to CA have been included twice? So when I subtract them twice, then the middle part that is common to all the three was neglected entirely. So I've added that part at the end. Simple, right? So now we are going to substitute the values. That is, this is going to be 150. Then we have what? We have A is going to be 71. Then we have 98. Then we have 68. Then we have this minus A intersection B minus B intersection C minus C intersection A plus your A intersection B intersection C. Correct? Correct. Now the point is that A intersection B intersection C is going to be 14 because 14 people opted for all the subjects. So I'm just going to erase this point and write 14 here. So here it will be what, your 14. So that means it will be 150 minus 71 plus 98 plus 68 plus 14 equal to negative of A intersection B plus B intersection C plus C intersection A. So this is your intersection. So this will be what? This will be your 251. I have like negative of 251 plus your 150. So I'm going to take this negative sign on the another side. So it will be negative of this, which is equal to A intersection B plus your B intersection C plus your C intersection A. I'm just going to erase a little bit so that I can explain you even more. So I'm just going to erase this part. Okay. So when we are going to solve this now, it will be what? It will be 150. Negative of 251 minus 150 will be equal to A intersection B plus B intersection C plus C intersection A. So this will be what? Equal to 251 minus 150. That is nothing but what? 250 minus 151 will be what? Come on. It will be your 101, right? But the number of students who chose exactly two subjects needed to be that we need to subtract something out of this. Now there is a catch. Okay. Now you people might be thinking that we are done with this question, but no. Let's just understand how we can avoid these kind of mistakes in question. Just give me a second. Let me read all of it. Alright. Now the point is we figured out that it is 101. But also the students who have opted for all the three subjects, they have been counted thrice. Because A intersection B plus B intersection C plus C intersection A. That means I need to subtract what? 14 three times out of it, right? Because they have been added how many times? Thrice. Because A intersection B and B intersection C and C intersection A, right? So if I'm going to draw them, actually it came out to be wrong. Let's just draw them again. Okay. So what I'm telling right now is that this is your A, this is your B and this is your C, right? A, B, C. Now in A intersection B you have included all this part. In your B intersection C you have included all this part. And your C intersection A you have included all this part. Don't you think that the middle portion is included 3 times and you do not want to include the middle portion? So that means out of your total number you need to subtract the middle portion thrice. The value of middle portion was 14 because 14 people opted for all the three subjects. So you need to subtract 14 3 times from the total number, that is 101 minus 14 times 3, which is going to be 59 students. So I hope you have understood the question, and you have like understood the hope, like you can say the horizon of the number of mistakes which you can make in questions like this. So always, just see that whether whatever you are solving is correct or not using Venn diagram. So just use the Venn diagram like I have used to analyze whether whatever answer we are getting is what is demanded by the question or not. So I hope you people have understood everything we have discussed till now about Venn diagrams. You can now go to EduRev and attempt these tests to understand this chapter in depth. You can unlock all the logged videos, documents and tests for CAT with EduRev Infinity Plan and ace your exams at less than 80 rupees per month. Thank you.